Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the 12th lecture on electrochemistry. In this lecture we are going to discuss two different things, very important things. That is, first we are going to discuss that is how we can able to calculate the number of moles deposited in the electrode by a given amount of electric charge or electricity. And second thing we will going to discuss, that is the product at the electrodes. That means the factor which are going to govern this product at the electrode. So two different things that we are going to discuss. So this is the first thing that we are going to discuss, that how to calculate the moles, that is the number of moles deposited on the electrode from the electric charge. For that, what we are going to discuss? First, we are going to write the reaction or the oxidation reaction. So for this, let us take the example of sodium ion aqueous. This is basically a reaction and it will going to produce the sodium solute. So here you can easily understand that 1 mole of electrons, 1 mole of electrons will produce 1 mole of sodium. Okay, so 1 mole of electrons, that is means 1 Faraday. So 1 Faraday electric charge is required to deposit 1 mole of sodium metal. Second, let us understand another Cu plus 2E and Cus. Here also you can see here you can see that 2 moles of electron, 2 moles of electron means 2 moles of electrons, that is the 2 Faraday of electric charge, will produce 1 mole of copper. Then another reduction reaction you can take. Here also you can see that 3 moles of electrons, 3 moles of electron, that is 3 Faraday of electricity, will produce 1 mole of aluminum. For a general equation, you can write this general equation, that is M metal, it has been reduced, that is the ions, cations of the M metal, which is having that charge, that is M plus, it will reduce to M solid, and in this case also you can see that N moles of electron, that is N Faraday of electric charge, produce 1 mole of metal. Okay, so from this we can able to understand, for producing 1 mole we required the electric charge according to the electron being transferred. In this case 1 electron is transferred for per atom. So for 1 mole it will be 1 mole electrons for sodium. For copper it is, you can see 2 moles of electrons is required. For aluminium you can see 3 moles of electron is required. This knowledge is very much helpful to solve many numericals. As for example, I am giving one numericals that will be related to this, that you can able to solve this easily. And this numerical is this. This is, suppose there is a galvanic cell, Daniell cell, and we know in the Daniell cell there is a 2 components, that is one the anode and the other is the cathode. In the anode you will find that a zinc rod has been deposited in the zinc sulfate solution. In the cathode, copper rod has been deposited in the copper sulfate solution. So we have taken 130 gram of zinc, suppose, and it has atomic weight is 65, and 1 mole of copper sulfate solution we have taken, suppose, and a constant, and from this cell we are producing constantly 1 ampere electric current, constantly 1 ampere of electric current, suppose, and you have to say how much time the battery lasts. The battery lasts. That is, you have to calculate that T. For this type of numericals, you would need the here what we have discussed this. Now, how do you solve this? Let us understand. So here you can see, first we have to calculate the moles of the zinc. Here moles of zinc is here 130 divided by 65 means it is a 2 mole. So here you can see, when you see the reaction of this, that is reaction in the Daniell cell, that is zinc plus copper sulfate, and it is produced zinc sulfate and copper. So you can see 1 mole of zinc will react with the 1 mole of copper sulfate. But in the cell you can see there is only 1 mole of copper sulfate is given, means it is a limiting reagent, because this compound, this amount of concentration will limit the reaction. Here it is 2 moles of zinc is there, so all the zinc will not be consumed here. Right? Now so far we have discussed this, how to produce. We have to see for this reaction how many amount of the electricity has been produced. That you can easily able to say that copper here is copper ion will be reduced, and for this we know 2 electrons is required and it is given this. So here what is going to happen, the charge, this means we need 2 Faraday of electricity to deposit 1 mole of copper sulfate. That we have 2 moles of electrons with 2 Faraday of electricity. So we will just write this. This is we can write equation, that is again we know amount of electricity, it is the amount of electric current force that is flows and the time. So amount of electric current is 1 ampere and this is time. This time we have to calculate T, and we need in this cell will produce this amount of electricity. So for this you can able to calculate the T, 2 into 96,500 divided by 1. So this is basically in seconds. So if we convert it into the hours, it will be coming around 53.6 hours. This will be the answer. So this cell, where you see the 130 gram of zinc and 1 mole of copper sulfate, and it is producing the 1 ampere current. In this cell you will find it will last for 53.6 hours. Now the second part of this lecture is product, prediction of product, prediction of product at the electrode. How do you predict? That we are going to discuss. There are several factors that is going to influence the product at the electrode during the electrolysis. That is the first thing, that is the nature of the electrolytes. Electrolytes may be in the aqueous solutions or maybe in the molten forms. Only the electrolytes ions will be there. But in the aqueous solution, you will find along with the ions of the electrolytes, individual electrolytes which furnish their own ions, there will be the H plus ion and OH minus ion, also the H2 molecules. So these are going to influence the product at the electrode. And another thing, that is the type of the electrodes. Suppose if the electrode is inert electrodes, as for example the platinum, or you can see the gold, where you can see it will not going to take part in the chemical reaction, only it will be the source and sink of electrons. It will never going to react with the electrolytes. But in case of other electrodes, which is also called attackable electrons, it will be reacted by the electrolytes. So in this case also you will find the product will be different. So first let us understand when we are using the impact of the inert electrodes on the electrolysis, and we are taking the example of aqueous solution of CuSO4, and this will be associated into the Cu plus 2 plus SO4 minus 2, and this is aqueous solution, so hydrogen also, H2 also been dissociated. So at the cathode there is a competition of this CO2 plus ion and H plus ion. At the anode there is these two ions cells. This O4 minus 2 ion H2 ion. So at the cathode, what will the product will be? At the cathode you will find the Cu plus 2 will be reduced to copper metal. So at the cathode there will be copper metal, but at the anode you will find that H2O is being oxidized. H2O is oxidized and it is going to give this product, that is oxygen gas plus so when we use the inert electrode, this product will be there. At the cathode it will be copper and at the anode it will be oxygens. But in case we use the copper electrode, then what is going to happen? Let us understand. In case of copper electrode, at the cathode we will find the same, that is copper metal. In the same way, same reaction is there. But at anode, this product will be Cu, copper metal will be oxidized. Here copper metal will be oxidized and here the product will not be oxygen. It will be oxidized by SO4 minus 2 ions. So SO4 2 minus ion will oxidize the copper metal and it will go to become a cations and it will go to the solution. So in this case you can see when you are using the inert electrode, there is basically copper metal has been deposited at the cathode and oxygen is liberated at the anode. Where in case of when you use the copper electrode at the cathode, you will find there is a same thing, that is copper metal is deposited, but at the anode you will find the copper metal has been converted into the copper ion and is goes to the solutions. So you can understand how this inert electrode going to influence the product at the electrode. And same thing we can observe when we use the AgNO3. AgNO3 with inert electrode, it will produce in the same way. At the cathode you will find the Ag and the anode is the oxygen. But at the when we use the Ag electrode, it will have the Ag at the cathode and Ag plus 2 ions will go to the solutions. So this is the first thing. Second thing, that is the nature of the electrolytes. First we have understand that is the electrode, inert electrode, the impact of the electrode, and second we have discussed, that is again important, the nature of electrolytes. Nature of electrolytes, that is basically it will depend on the which type of oxidizing or reducing species is available during in the electrolytes. So nature of the electrolytes, the electrolyte may be aqueous, electrolyte may be molten state. As for example, we are taking the example of NaCl molten. When we electrolyze this NaCl molten, what is going to happen at the electrode? What will be the product? Now, when NaCl is being electrolyzed and it will be dissociated, its molten will be dissociated, then you will find Na plus and Cl minus ion. And at the cathode we will find this, that is Na plus will be reduced to Na, and at anode you will find the Cl minus will be oxidized to chlorine gas. So in the case of when you neutralize the molten NaCl, in that case we will find that is the two product called sodium and another is chlorine gas. In case of when we are using this aqueous solution of NaCl, then what will be the product? Now we are going to discuss. When we electrolyze the aqueous solutions of NaCl. So here you can find the product is different. What will be the product? Product in this case, you will find at cathode we will find hydrogen gas. At anode we will find oxygen gas, and in the electrolyte solution we will find electrolyte solution we will find with NOH aqueous. So that is a totally contrasting. When we electrolyze the molten NaCl, at the time what we will find at the cathode it is Na and the anode it is chlorine minus, but here at the cathode it is find hydrogen and at the anode it will be chlorine. At the anode it will be chlorine gas, at the cathode is hydrogen gas, and electrolyte will be in the electrolyte will be find with the NH. How it happens? Let us understand. In the NaCl, the aqueous solution of NaCl, you can easily able to understand that it will having the sodium plus ion, Cl minus ion from the NaCl, then H plus ion and OH minus ion from the water. So what is going to happen at the cathode? At the cathode you can find there is a competition of between these two reactions, that is Na plus this and it is having ECl is minus 2.71 volt, and another reaction that is you can see H plus E half hydrogen gas, and is ECl you know that is 0. So here there is a two reduction reaction you can see, one sodium taking up the electrons and hydrogen taking up the electrons, but which reaction is going to happen, that will be determined by its electrode potential. The here reduction potential, whose reaction will be higher, it will be getting the preference. So here you can see this will get the preference. So we will find at the cathode that is the hydrogen gas. So how this reaction, we can write this reaction because hydrogen ion is coming from the dissociation of the H2O. So we can write this H2O is equal to H plus plus OH minus. So we can write this equation, this reduction equation with this H2 plus hydrogen, it will be half H2 plus OH minus. This hydrogen I will cancel out. So this will be the overall cathode reaction and it is going to happen. It will get the preferences. Now we comes to the anode. At anode, what we will get? Let us understand. At anode again there is a two anions, that is one is chlorine minus ions, it will be oxidized and it will going to create the chlorine gas plus one electron, and its electrode potential that we are going to see, it will be this 1.37 volt, the reaction potential. Whereas another reaction that we can see, that is H2O is also there is a probability of oxidized, and it will be oxidized and going to produce the oxygen gas, plus it will produce plus 4E, and its electrode potential is 1.23 volt. So if we go by the electrode potential, naturally this reaction will be preferred, that is the oxidation of H2. But due to the over potential factor, because in this case although electrode potential is 1.23, but when we are going to liberate the oxygen, it will require higher potential, and this high potential will not be allow this reaction as a preferred reaction. So this reaction will be preferred although it has the higher reduction potential, means it will not going to be oxidized as compared to this, but due to the over potential this reaction is going to be there. So what will be the overall reaction? Let us understand. Overall reaction will be, we can see the initial, it will with the H2O, it will become Na plus aqueous plus Cl minus aqueous. At anode, or you can say at cathode, first better write the cathode. Cathode, the reaction will be H2O plus this, and it will be half H2 plus OH minus. At anode, this reaction will going to happen, that is Cl minus half Cl2 plus electron. So here what we find, the reaction is this at the electrode, that NaCl plus H2O, it will produce the Na plus OH minus plus half Cl2, this is gaseous form, and half H2 in the gaseous. So here you can see at the cathode and anode, this is at the cathode hydrogen and the anode it is a chlorine, and at the electrolyte solution you will find this will be NaOH. So we understand how different factors are going to influence the product at the electrode. Another thing, that is the concentration. In the case of concentration also going to impact, that we will now discuss. In the lecture number 4, we have discussed about the Nash equation, and most probably you can remember this. Lecture number 4, that is Nash equation. Nash equation. In the Nash equation, what we understand, the electrode potential is going to influences by the concentration of the electrolytes. And in this case also you can find the concentration of electrolytes. Concentration of electrolyte is going to influence the product during the electrode. Concentration of electrolytes. How? That is, when we analyze the concentrated electrolysis of concentrated dilute H2SO4, versus concentrated H2SO4. In this case, what we will find, different type of product, and both the cases you will find that at the cathode, there is hydrogen, liberation of the hydrogen. At cathode, H2 is liberated. No problem in this case. But at the anode, there is a two reaction you can see, because there is a two in the concentrated, there is a, and one is OH minus ion, and other there's hydrogen H2 will be oxidized, and SO4 minus 2 ion will be oxidized. Though there will be the two reaction is there. So in the anode you can see at anode you can write the H2O is oxidized and it will going to produce oxygen gas plus 4H plus 4E. This is the oxidation reaction of the H2 at the anode. And another reaction that we can see is SO4 2 minus, it will be oxidized and it will going to produce these ions plus 2E. When there is a high concentration at this time, this reaction will be the preferred reactions. And when it is dilute, the acid is dilute, at the time this reaction will be preferred. At the time we will find that the anode oxygen is there, or when it is concentrated, at the time we can to part disulfuric acid is going to be produced at the anode. So how the product and the electrode is being influenced by different factors that we have analyzed in this lecture, that is basically the type of electrodes, then we have discussed the type of electrolytes, and then also the concentration of the electrolytes that is going to influence. So that is all for today's lecture. In this lecture what we have discussed that it most probably been understood to you. If you like this lecture, you can share to your friends. Thank you very much for watching.